Good morning, my dear student. Today we'll talk about Unit 1, Lesson 1. Any body has two states. It may be at rest or at motion. Let's start to explain video to talk about types of motion.
We say that tree is stationary. That means a tree does not move. Similarly, a house, school, electric poles are all stationary objects which remain fixed at one place. On the other hand, a man, animals, ships, aeroplanes, etc. do not remain stationary. They move from one place to another. Therefore, the movement of body or objects is called motion. There are mainly two types of motion, uniform motion and non-uniform motion. A body has uniform motion if it travels equal distances in equal intervals of time. For example, a car running. A body has a non-uniform motion if it travels unequal distances in equal intervals of time. For example, a ball dropped from a roof. The motion of a body can be described by three terms: speed, velocity, and acceleration. Speed of a car A is low and speed of a car B is fast. Thus, the speed of body gives us an idea of how slow or fast that body is moving.
تعالي يا صباح. تعالي خدي الكوبايه وهاتي لي ازازه ميه وما تفتحيش عليا تاني عشان بتنيل بسجل. So what is meant by motion? It's a change in object position as time passes. The motion may be in a straight line or in curved line or in both. When we talk about the simplest type of motion, we will mention the train motion because it moves in a straight line in one direction.
One-dimensional motion. As we look at our surroundings, we will find many objects at motion and many at rest. In a real sense, motion and the state of being at rest are profound topics. Let's try to have a better understanding of these subjects. Consider a man sitting in a park as a squirrel runs by him. The man is at rest with respect to his surroundings. The squirrel is in motion with respect to the man. Now, consider the earth and the moon. With respect to the moon, the earth is in motion, and so the man is also moving. Here, the moon is a frame of reference. Therefore, an object is said to be in motion if there is a change in the position of the object with respect to the frame of reference. So far, we've discussed motion and frame of reference. Let's now understanding the meaning of distance and displacement. A bus moves from destination A to destination B. In its course, it changes its direction constantly and reaches destination B. In the process, the bus has covered a distance of 2000 meters. The length of the path covered is called distance D travelled. Here the moving body has only magnitude, no direction, and hence distance is a scalar quantity. Now, let us consider that there is an alternate route which takes the bus to the destination B in the shortest distance, that is 1500 meters. The straight distance between the initial and the final positions of a moving body in a particular direction is called its displacement. Here, the moving body has magnitude in direction. Hence, displacement is a vector quantity. Let's now discuss speed and velocity. Speed is the distance travelled by a body in unit time. Consider an object moving from destination A to destination B at a certain time t, that is 600 seconds. The distance d between the point is 2000 meters. Let's calculate the object's speed. Speed is equal to distance d by time t. 2000 by 600 is 3.3. The SI unit of speed is meter per second. This is represented by the symbol ms to the power of -1 or m/s. When we calculate the displacement of the object between the same points per unit time, we will obtain its velocity. That is, velocity is the rate of change of displacement. So velocity v is equal to displacement by time. That is, 1500 by 400 is equal to 3.75. The SI unit of velocity and speed is meter per second. What happens when a body moving in a certain direction changes its speed suddenly? Let's consider two vehicles moving in parallel with uniform velocity, that is 10 meters per second from point A to point B. Suddenly, one vehicle increases its velocity, that is 15 meters per second in 3 seconds, and speeds off towards point B. As the velocity of the vehicle has increased, it is said to have accelerated. Acceleration is calculated as the rate of change of velocity. That is, acceleration A is equal to change in velocity by time. Here, change in velocity is 15 meters per second minus 10 meters per second, which is 5 meters per second. T is equal to 3 seconds. Therefore, acceleration A is equal to 5 by 3, which is 1.6 meters by second square. Things to remember. Motion is the change in position of an object with respect to a frame of reference. The length of the path travelled by a moving object is called distance. Distance is a scalar quantity. Displacement is the distance travelled by an object with a certain magnitude. Displacement is a vector quantity. Speed is the distance travelled by a body in unit time, and velocity is the rate of change of displacement. The SI unit of velocity and speed is meter per second. Acceleration is calculated as the rate of change of velocity. The SI unit of acceleration is meters by second square.
So we have a question in this part. Give reason for train motion is considered a motion in one direction because it moves in a straight line forward or backward, not upward or downward. Speed. Speed, it's the distance covered in a unit time. So speed rule will be speed equal distance in meter or kilometers divided time in second or hour. So the measuring unit of speed will be meter per second or kilometers per hour. And the rule will be speed, velocity V equal distance D divided time. Calculate the speed of a swimmer who swam 120 meters in 1 minute. In order to solve this problem, you have to change the time from minute to second, and the answer will be speed equal distance divided time, V equal D divided T, 120 meters divided 60 seconds. So the body speed will be equal 2 meters per second. On speed. There are two factors affecting on speed. The first factor, distance, and there is a directly relation between speed and distance, because by increasing the distance covered by body, the speed increase and vice versa. Second factor is the time. There is an inversely relation between speed and time, because by increasing time taken by the body to cover distance, the speed decrease and vice versa. Let's practice this part complete. Speed is affected by distance and time. Number 2, speed, space as a time decrease, speed increase as a time decrease, because there is inversely proportional between them, and speed increases as a time or as a distance increase, because there is a directly proportional between them. Of speed are uniform speed, which is known as regular speed, and the second type, non-uniform speed or irregular speed. 3 graphs explain the different type of speed. The first graph explain uniform speed. It identified by straight line passing by intersection point between time axis and distance axis. Second graph explain a body at rest. So the axis of distance will be parallel to the axis of time. Third graph explain the relation between distance and time in case of non-uniform speed, and it will explain by curved line. We talk about what is meant by a body moves with a uniform speed 80 kilometers per hour. This means that the body covers 80 kilometers every 1 hour. When I ask a body moves with non-uniform speed, so what is meant by this sentence? You will explain that this means it covers unequal distance through equal period of time or equal distance at unequal period of time. To identify or to determine non-uniform speed, we use another concept which is known as average speed. Average speed, it's the total distance covered divided by total time taken to cover this distance. The rule will be V, velocity, equal total distance divided by total time. And its measuring unit equal meter per second or kilometers per hour. The average speed. Find the average speed of a car moves in a circular path, its length 300 meters for 3 rounds in 3 minutes. So the distance will be, this car covers 300 meters in 3 rounds. The distance will be 900 meters, and the time in second will be 3 minutes multiply 60 equal 180 seconds. So the total distance divided by total time to find the average speed, 900 meters divided 180 will be equal 5 meters per second.
Relative motion of objects. Have you ever wondered as to why a train coming from the opposite direction appears to be faster than a train moving in the same direction? To answer the above question, we have to understand relative motion of objects. Consider a passenger sitting at the window seat of a train as an observer. Case 1. When the train in which the observer is sitting is moving with a velocity v1 of 30 km per hour, and another train is coming towards the first train with a velocity v2 of 60 km per hour. In this case, from the frame of reference of the observer, it appears that train coming towards him is moving faster at a speed of 30 plus 60 is equals to 90 km per hour. Whereas, from the frame of reference of a person standing on the station, both the trains are moving with velocities of 30 km per hour and 60 km per hour. Hence, in the case of train moving in opposite direction, from the perspective of the observer sitting in one of the train, it appears that approaching train coming from the other direction is moving faster with net velocity being the sum of v1 and v2. Case 2. When both the trains are moving in the same direction with same speed of 60 km per hour, that is, v1 is equals to v2 is equals to 60 km per hour. In this case, from the frame of reference of observer, it appears that the other train is stationary. But from the frame of reference of a person on the station, both the trains are moving at a speed of 60 km per hour.
So, after we explain this video, you can identify the definition of relative speed. Relative speed, speed of the moving object relative to the observer. So I can say that relative speed depends on the position of the observer. When the two bodies move in the same direction, relative speed equal v2, v1, negative v2 when objects move at the same direction. When the two bodies move in opposite direction, so relative speed will be equal v1 plus v2 when objects move in opposite direction.